Afternoon, ladies and gentlemen. I would like to thank you all for being here today. My name is Eyhab Al-Masri. I'm an assistant professor at the Institute of Technology. The title of the project is Transforming Computing Education Using Experiential Learning. The overall idea of this project is to add more hands-on experience for the students when they take computer science courses. In particular, I would like to go over the motivation for this project, and then I will share with you some of the recent results from teaching courses that has the experiential learning aspect. So as we are all aware, the computing education is widespread. It has reached multiple disciplines. It's not only confined to computer science, it has reached social sciences, business, among many other disciplines. And the interest in computer science is increasingly growing. And this is obvious by the number of tutorials that are available online, the MOOC courses. Recently, for example, Google yesterday, they have published that they will be offering their own certificates. Lots of companies are offering their own certificate programs as well. And computing has been an essential tool for our daily life activities. So how important is this? When teaching computer science, and when you see SE is basically software engineering, CS is computer science. So CS and SE departments are likely to teach not only students who have the basic skills, but actually more of diverse students that are diverse in terms of their background skills, the background knowledge when it comes to technology, for example, and also their technical abilities. So it becomes challenging to teach students who have these different backgrounds and different types of skills. So the focus is on three main challenges. How should we teach CS and SE or software engineering courses to this diverse group of students? And how can we assume that teaching, how can we ensure that teaching approaches scale effectively? So for example, if you're teaching a small class, and then with a growing number of students over the years, you need to scale that course, for example, for a larger audience. And most importantly, how should computing be taught and integrated into other disciplines? So you might find courses, for example, in business that might be interested in integrating some of these technology modules into their courses, which sometimes for faculty can be time-consuming. We also need to take into consideration some of the implications, such as, for example, guiding students to work on their own, i.e. some sort of a self-directed learning. Students need to learn not only within the classroom, but also beyond the classroom environment. And also how to balance this self-directed learning with the formal approaches, i.e. the traditional approaches, by giving them the teaching within the classroom environment. So having these motivations, what are really the goals of this project, which I consider to be a starting point for a larger project, is to bring together computing educators and also researchers to think deeply about the learning outcomes. That is, we are not trying to finalize these outcomes or assessment, but help identify the most important ones. The goals of this project are twofold. First is to have the ability to integrate course modules using hardware prototyping platforms. Some of you may have heard, for example, for Arduino, Raspberry Pi, Galileo, lots of hardware prototyping platforms, which enable students to become more active in terms of the topics covered in CS and SE courses. As well as the second goal is to bridge the gap between industry and what we teach students in class. So in other words, bring industry fellows, for example, to have their own say on the material that is being covered within class. I will focus in the next few slides on software engineering, the SE discipline. SE is a huge discipline when it comes to computer science and also software engineering and engineering in general. Software engineers, they mainly face decision dilemmas. In other words, majority of the work that they work on is they have a problem that they need to solve and they have to make decisions. Right? So we would like to help students to make the correct decisions as much as possible. And the way they do that is using the best practices. And these best practices, they constantly change as technology evolves. So the ability for self-directed learning is critical. That is, it's important for the students to expand their knowledge beyond the typical classroom environment when it comes to software engineering courses. And many software engineering educators are exploring non-traditional course delivery methods. So for example, using course-based or using, for instance, hands-on experience, which is the topic of this project, the experiential learning. Just to give you a sample snapshot of a very recent ad from IBM, for example, that I actually came across today. This is a typical essential skills required from a software engineer who is a recent graduate. Right? If you notice carefully under the essential duties, the second item, take ownership and manage projects throughout the entire life cycle. A typical software engineer course would try to teach students the basic best practices, but they will not have these hands-on experience to be able to take ownership of an entire project. And these are typical ads that you will find across many organizations such as IBM, Google, and so on. And if you notice under the required technical portion, in addition to the list of programming languages such as PHP and other languages, 2 years of professional programming experience. The students, when they finish the course, they may not have that lengthy time of professional programming experience. This is another software engineering position ad from Google. You'll see that the minimum requirements require a bachelor degree, but the preferred is actually a master and also a number of years in terms of programming experience. So to illustrate this importance of trying to add this experiential learning portion into computer science and SE courses, I will discuss one course that I taught in the past, and I will compare the results or some of the results that I actually have collected from using experiential learning and non-experiential, i.e. traditional approach. So the title of that course was Principles of Software and Requirements Engineering. Requirements engineering is a major portion of software engineering in which students or in which software engineers, they collect requirements about the system that to be created. So during the winter of 2013, I taught a group of 47 students. It included a lecture of about 3 hours per week, 2 lectures, 1.5 each, and a lab component of 2 hours. It was a difficult course to teach in the sense that you teach theoretical ideas, i.e. all these best practices, and the students do not see an actual tangible product in which they apply all these best practices throughout the semester. They may work on a project, but sometimes these projects may not reflect the real world. At the end of the semester, based on the course evaluations from the course evaluation component itself, only 50% of the students thought that this course has contributed importantly to their overall program study. So taking all this into consideration, and sometimes you do not get to teach the same course again and again, but I had a chance to teach that course a year later, and I decided to actually integrate an hands-on or experiential component into this course. In the lab portion, you'll see, for example, that I asked the students to build a prototype using an actual hardware prototyping platform. So I made these prototyping platforms accessible to students, and then they work on a project that mimics the real world. That is, there is an actual client who has a problem that they need to solve, and then they actually demonstrate a prototype at the end of the semester that basically tries to solve partially that problem that was initiated. So this increased the students had to present at the end of the semester a presentation that reflects how they learn solving the problems that you were given, and also how does the project improve their knowledge and understanding the SE as an overall discipline. Just to share with you some of the results, you will see, for example, at the top that majority of the students believe that the hardware prototyping platforms has increased their interest in engineering and SE, and majority of the students believe that working with hardware prototyping platforms has strengthened their intellectual curiosity. And that is the whole idea of adding this hands-on component, is that students begin to think beyond the typical environment. Some of the lessons that I learned from teaching these courses is that, and it's a typical fact, computing is rapidly changing. There are lots of technologies that are evolving almost on a daily basis, and self-directed learning is crucial. That is, we need to prepare students so they can actually go beyond the typical classroom environment. We're teaching this course, again, with the hands-on experience component, the same survey, which is the course evaluation, 87% believe that the course has made a contribution or significant contribution to their overall program. In terms of another course that I have taught recently in UWT, I just joined last semester. I taught this course, which is titled Software Development and Quality Assurance, TCSS 360. It's a software engineering class. The requirements are a bit different from the previous courses that I have taught, but I had 39 students, lectures 3 times a week. I use a different teaching model. I use an inverted class model in which I actually ask the students to read the material ahead of time, and then I give them a case study in which they have to solve within a group within the time of the lecture. So in other words, they have to prepare beyond the class, before the class, and then they work on some in-class activities, which are basically case studies. I also invited, for this course, I invited guest speakers from industry to give students insights about the current best practices that exist in industry and how they actually solve real-world problems. So I had a chance to bring Eric Peterson from Accumula and also Mike Brown from Infoblox. Just to share with you some of the observations from a survey that I administered during the final week. 33 students participated, and you can see that the majority of the students believe that these guest speaker sessions has helped them increase their knowledge in computer science and SE in general. So if you take a look, for example, in the third one, I recommend having guest speaker. Majority of the students have said strongly agree or agree in general. And these are some of the reflections from the students on the guest speaker sessions. Perhaps I would like to share with you maybe on the next slide. This is one of the students writing, I'm very curious to know what it would be like to start a company. So in other words, the student now is thinking in terms of actually entrepreneurship. They might think of actually creating their own company. Now they have a role model from industry who's successful, and they can follow that role model. So in focus, the plan for this project, as again, it's twofold. The basic idea is to use hardware prototyping platforms to create course modules which can be integrated into classrooms across many disciplines. And so for example, there would be a course module introducing Arduino or the Arduino environment, some sort of a hardware prototyping platform, or another module, for example, to connect a sensor and then send the data into a back-end system, which any other department across the university can easily use that course module or integrate it along with the labs and the solutions and the PowerPoint slides for each module. So as a faculty, you would not have to spend a lot of time into researching how to use more Arduino or any of these hardware prototyping platforms. If you would like to add a hands-on experience component into your class, then basically you can use all of these built-in or the components that we will work on to create. So that is, I will work with in hiring 2 to 3 students who will create these course modules, and these course modules will be available publicly across the campus. And at the same time, I would like to consult with industry leaders, particularly Infoblox has initiated their interest into providing insights on the types of course modules that can be integrated and how it can help students learn or acquire the knowledge or the skills needed. So the overall aim is to actually collaborate with industry leaders, particularly the local community in here, Infoblox. We have Cloud PR. I will also be working with some software engineers from Amazon and Microsoft who can actually be serving as a consultant to come up with these ideas for these course modules. So the overall aim is to make classrooms more experiential. And it's very critical nowadays when it comes to computer science that students have the hands-on experience when they work in industry, so they are prepared and be confident when they apply for jobs. These are some of the references that I use for this PowerPoint presentation. And just to give you an overview of myself, I actually finished my bachelor in computer engineering and my master in electrical, and then I had a chance to work in industry, and this is where I have seen the power of industry, and using the skills I need in industry, I was able to accomplish my PhD and do well and excel in my PhD, which I finished in computer science. So I have been around all these 3 different disciplines, and I can see the power of connecting all these disciplines together. I'm also proud to say that I'm part of the WebConf conference, which is the top conference in the world. It's governed by the W3C, the organization that handles all these web development environments or the web programming languages. Part of the workshop this year, we actually accepted a workshop on education and knowledge discovery. And last year also, I have been a member of the digital learning research track that is part of the WWW 2017. So education has become an important and integral part of research as well in the last few years. Thank you all for listening. If you have any questions.